well, hopefully those of you watching did better on your quiz than some of the folks in here. It sounded like it was not a good quiz for them. As I said to them, you know how to study now. Okay, this is 2 quizzes. Basically, as I told you at the beginning, memorize everything. So study, memorize, and hopefully we'll do better. I also told them this, we have a lot of quizzes in this class. Okay, so study, and on the next quizzes that we'll have, and we'll have many, do really, really well to pull that quiz average back up if you've been struggling on the first couple. Terms definition section of your notebook. So we've got all the stuff that we've already learned we need to be studying. Let's add some more notes to study, which is why you have to study every night because I keep adding more. Terms definition section of your notebook. Fortunately, there's not a whole lot of notes today, so you have a chance to kind of catch up a little bit if you've been falling behind on your studying. Once you write this term down, the term degree, and the symbol is a little degree symbol, as you should already be familiar with. A degree is defined as 1/360th of a paragon. 1/360th of a paragon. Now, it seems like a bit of a random number if you didn't already know that, hey, there's 360 degrees in a full revolution, right, to a 360. But where did that number come from? Well, the full turn was divided by the Sumerians into the 360 parts. The thought being they wanted a number that could be divided a lot of different ways. And 360 is divisible by 2, 3, 4, 5, 6, not 7, 8, 9, 10, not 11, 12, not 13 or 14, but 15, by 18, by 20. 360 of all numbers is divisible by some of the most numbers out there. So that's where the number 360 came from. Also kind of the thought at that time that, 360 was the approximate number of days it took to complete a full yearly cycle. So for all of those reasons, 360 was chosen. So it's not so much that a paragon is defined as 360 degrees, but that there are 360 degrees in a paragon because the degree was a 360th of a complete turn. Does that make sense? Now, some things we can derive from that, because remember, a straight angle, part of its definition is it's half a paragon. So because of this definition of the degree, how many degrees are in the straight angle class? 180. Also, a right angle, part of its definition is half a straight angle. So therefore, a right angle is how many degrees? 90 degrees. Not because a right angle is defined as 90 degrees, but because of the way in which we define the degree and the way in which we define a right angle, we now have a right angle being 90 degrees. So for that reason, then, you might just kind of tuck this thought away. What's an acute angle, then? Anything between
90 and
0 and 90, right? If we were to write it the way we did in Algebra 1, we could say that the angle x is greater than 0, but less than 90, right? Or guys who had Algebra 2, using what we call the interval notation, we'd say between 0 degrees and 90 degrees, right? But with parentheses, not brackets, because we're not including 0 or 90. A 0-degree angle is not acute. A 0-degree angle is a line. A 90-degree angle is a right angle, but so no or equal to for those who had Algebra 1, but that would be acute. What about an obtuse angle?
anything from 90 to 180.
Between 90 and 180, not including 90, again, that's right angle, not including 180, that's straight angle, but anything between 90 and 180. What about a reflex angle?
Anything between 180 and 0, or 180 and 360.
Good, anything between 180 and 360, greater than straight angle, but less than a paragon. So we can define our acute and obtuse and reflex angles, I suppose, in these terms, to right angles, straight angles, in these terms, now that we understand the degree, but that's not the definitions we'll typically use in this class. We can further divide the degree, though, down into smaller units called minutes. So the next term is the term minute. It's going to be notated by a single tick mark, raised like the degree symbol is, a single tick mark, and we would say that a minute is 1/60th of a degree. We're used to saying there are 60 minutes in an hour. That's true, but for geometry, we would say there are 60 minutes in a degree. For that matter, we could further subdivide minutes into seconds. So a second, notated with a double raised tick mark, is defined as 1/60th of a minute. Conveniently, that's the same definition we have for time. Okay, so a second is 60th of a minute. We're like, man, that gets really detailed. I mean, if you look at the protractor, and my protractor for the chalkboard doesn't even have individual degrees, it just has every 5 degrees. And you're like, well, this has every degree in it. A degree looks pretty tiny, doesn't it? That almost a little bit more than a millimeter apart from each other on here. But you're saying you can break that down even smaller. Well, yes, because on our paper, our angles might not be very big, right? But imagine now for a moment if a ship captain is supposed to plot his course, and he's 1 degree off. Well, a trip of 1,000 miles across the ocean, and all of a sudden a degree off, he's 50 or 60 miles off port. The Pilgrims got just a degree or 2 off. They were supposed to go to Virginia. Didn't work out. So that wasn't so much their fault as much as it was, the storms and all that they faced. Or on maybe a more fun note for the guys, if you're, launching a missile attack at, someone or something. What? Russia, Korea. Okay, so you're launching a missile attack. Can you imagine if there's, nowadays, back in World War I, World War II, the idea was just bomb everything you can. Now we live in a more civilized society. We only want to bomb strategic targets, killing as few civilians as possible. Which, since I'm a civilian, I really like that. Okay, so imagine, heaven forbid, Fort Benning ever came under attack. It'd be a real bummer if they missed, because they were, a few minutes off, and they blasted Grace Christian School instead. Okay, that would be a bummer, because I'm just, an innocent civilian trying to live my life, And so anyway, or, we try to blow up Korea, and there's a strategic target, military headquarters with all the top, evil minds of the regime, and you miss, and you blow up an elementary school or something. Well, you totally didn't achieve your objective, but now we're plunged into a nuclear war. Where if you'd blown them up, maybe we could have avoided the nuclear war because the people left over wouldn't have wanted to start one in the first place. So you want to blow up the bad guys. There was that second leading guy in Iran, the Ayatollah Khamenei's regime, but the second leading terrorist, and we blew up his car. With a drone missile attack. Okay, we could get that exact, and granted, part of it is radar-controlled missiles and stuff like that. But when you can get very, very detailed, like we can with minutes and seconds, I mean, think about this now: 1/60th of a minute, which is a 1/60th of a degree. So now we're getting to 1/3000. You can break every degree down into 3,600 parts. We can get pretty accurate with that. So that's the reason more for that. We won't have to actually draw with our protractor, which we'll use tomorrow. We're not going to have to draw things quite that detailed. But you understand, when you get off the page and you start launching missiles or trying to fly a plane across an ocean or sail a ship across an ocean, now the exact details matter quite a bit. As far as how we read these angles, let's go and look at page 15. Page 15, look at number 3. Look at number 3. How would we read these angles? Page 15 in your textbooks. You can actually, just keep your notebooks out. We'll get back to them in a second. But page 15, look at number 3. Look at that first angle. You literally read exactly what it says. We don't actually insert the word "and" anywhere. So that first angle is literally read 15 degrees, 17 minutes. Okay, understanding what the symbols mean: degree, minute, second. Okay, if there's more than 1 degrees, minutes, seconds. So what about that next angle, Ethan? How do you suppose we would read the next angle for number 3?
89 degrees, 46 minutes, 57 seconds.
Perfect. 89 degrees, 46 minutes, 57 seconds. Kendall, nice and loud. How about number 3?
156 degrees, 35 minutes, and 42 seconds.
Good, and we don't even need the word "and" in there. We just go 35 minutes, 42 seconds. But yeah, pretty straightforward as far as how to read the angles. Just making sure we can sound intelligent when we get to them. Jumping back up to number 2, it asks, what kind of angle is each of the following? So class, call it out to me. 37 degrees? That's acute. 105 degrees? Obtuse, it's greater than 90. 76 degrees? Acute. 147 degrees? 169 degrees? 89 degrees? Barely acute, right? So just barely acute. But to the naked eye, it might actually look like a right angle. 15 degrees. 179 degrees. 180 degrees. That's a straight angle. What about 205 degrees? Reflex. 360 degrees. paragon is what we call it. Okay, there are 360 degrees in a circle. If you were to trace the outside of the angle all the way around, it would be a circle. 90 degrees. Right angle. There we go. All right, now, with this, I want to tie a couple thoughts together then that we talked about last time as we discussed this idea of complementary and supplementary angles. And we said complementary angles are how many angles, class? Two. So a single angle is never complementary. Two angles together are complementary. Okay, they have to be in pairs. And together their sum must be a right angle. That makes complementary angles. How would we find the complement of an angle? Turn to your class notes section of your notebook. Class notes section of your notebook, the very last section. Frankly, a lot of this section is anything you want to put in there, you can. But periodically I'll tell you things I want you to put in there. And when it comes to the graded notebook at the end of the quarter, I'll be looking for specific things that I told you to put in there. The first thing I want you to put in there is finding the complement of an angle. Finding the complement of an angle. Really straightforward. If complementary angles are two angles that add up to a right angle, and we said that a right angle, because it's half a straight angle, which is half a paragon, is 90 degrees, then to find the complement of an angle, you'll simply take 90 degrees minus the angle. 90 degrees minus the angle, which is really, really easy. So for instance, if we had 70 degrees, what would the complement of 70 degrees equal, Audrey? 20 degrees, because you do 90 minus 70. What about the complement of a 46 degree angle, Chris?
44.
Good, 44 degrees, right? So pretty straightforward, you just subtract from 90 degrees, right? To find the supplement of an angle. Finding the supplement of an angle. Well, again, supplementary angles. That's two angles whose sum is a straight angle. So for a straight angle, since the sum is 180 degrees, my formula is going to be 180 degrees minus the angle. So instead of 90 minus, it's 180 minus. Pretty straightforward. Now, it seems easy as long as we're doing something like this. For instance, if we wanted to find the supplement of 73 degrees. And of course, you can, by the way, use your calculators. I did tell you to have your calculators handy for this lesson. But what would be the supplement of 73 degrees? At 107 degrees. You may or may not need a calculator even for this, right? Just subtract from 180. It gets a little bit more dicey though if you were to say, well, let's find the complement of 64 degrees 11 minutes. So do this with me there in your notebook in the class notes section. If we want to find the complement, first of all, remember we said we're going to subtract from 90 degrees. So 90 degrees minus 64 degrees 11 minutes. The problem is, as you remember from your early days of learning subtraction, you can't subtract something from nothing, right? You can't subtract 11 minutes from no minutes. So we're going to have to borrow. We're going to borrow 1 degree, which leaves us with how many degrees right here, class? 89 degrees. And that 1 degree is going to come over here, but how many minutes are in a degree? 60. So I don't bring it over as a 10, I bring it over as a 60, because we're not looking at place value. That's why we always made it a 10, right? But it's not place value here. It's a degree turning into 60 minutes. So you're doing this with me. And now we subtract. 60 minutes minus 11 minutes. 49 minutes. There we go. And we've got 89 degrees minus 64 degrees. And there we go. So even if there happen to be degrees in minutes, well, we just borrow. What if it said find the supplement of 64 degrees, 11 minutes? Well, instead of subtracting from 90, class, to find the supplement, we would subtract from 180. But once again, same problem as before. You can't subtract minutes from no minutes. So we're going to borrow a degree, right? 179 degrees, and that 1 degree comes over as 60 minutes. There we go. And then we subtract. Well, again, 60 minus 11 is still 49 minutes, but 179 minus 64 115 degrees, 49 minutes. Make sense?
Yep.
We could do this with degrees, minutes, and seconds, in fact. Let's go ahead and look at one of those. Suppose we had an angle that was 13 degrees, 56 minutes, 44 seconds. And we wanted to find the complement. Well, again, what does the complement mean, Ethan?
Defining. That is,
What do we do to find the complement?
you subtract 90.
Subtract from 90, right? Because complementary angles add up to a right angle, which we said is 90 degrees. But we can't subtract minutes from nothing, so we're going to, Ethan,
Take away from 90. 89.
and then that 1 degree comes over as
60.
60 minutes. But we also can't subtract 44 seconds from nothing, so we have to borrow again. This time, we're going to borrow from the 60 minutes, which gives us how many minutes, Audrey? 59 minutes, and that 1 minute comes over here as 60 seconds, because we said there are 60 seconds in a minute, 60 minutes in a degree. And so it's kind of a double borrowing thing that we have to do, which again, you're familiar with from normal subtraction. And Kendall, what do we get for our answer here?
16 seconds.
Good,
3 minutes.
good.
And 76 degrees.
There we go. So we get 76 degrees, 3 minutes, 16 seconds. What if, though, we, instead of finding the complement, we wanted to find the supplement? Well, again, very similar, except this time, Chris,
You're going to do it by 180.
let's subtract away from 180 degrees. But again, we're going to have to do the double borrowing. Chris, walk us through it.
179 degrees, 59 minutes, and 60 seconds.
Good. As a reminder, Chris did all this in his head, but of course he knew if I bring over 60 minutes, I'm going to borrow one of those minutes anyway to make the 60 seconds. He's like, hey, I'm lazy. I like it. We're just going to go straight to the 59:60. And so, Chris, when we subtract now, we get
166 degrees, 3 minutes, and 16 seconds.
and there we go. Any questions on how to find the complement or supplement? It's still 90 minus and 180 minus for complementary and supplementary, but when there's minutes and seconds involved, we just have to borrow. Any questions on that?
Okay.
All right, I want you to do numbers 4 and 5 at your seats. Page 15, numbers 4 and 5. You can continue working on the same page of class notes, or you can do it on scratch paper. It's up to you. Hey, it's a nice change, right? We're actually doing math.
Yes.
Does it feel good?
Yes.
Actually doing math in math class again? It won't last long, but enjoy it while it's here. And of course, that's one of the reasons why we do practice exercises, because it gives you a chance to do at least some math in math class. Is finished?
4 and 5.
Oh, 4 and 5. He's finished with 4. Now Chris is finished. Set the water down beside your desk just so there's not a chance of spilling on things. Take about another minute to finish up, and then we'll take a look at your answers together. Ethan's finished. Audrey's finished. And pencils down. Pencils down even if you are not finished. Looks like we had 11 answers, and we'll see. Chris was the first one done. We'll see if he got all 11 correct. If so, he gets the candy. If not, we'll go to Ethan, then Audrey, and then finally I'll get the candy. All right, so we start with Chris. Number 4, what was the complement of a 72-degree angle?
18 degrees.
Very good. For 35?
55 degrees.
48 degrees, 24 minutes.
41 degrees, 36 minutes.
65 degrees, 48 minutes.
24 degrees, 12 minutes.
And 84 degrees, 56 minutes.
5 degrees, 4 minutes.
Perfect. How many also perfect on all the complements? Excellent. Now, for those who had the time, let's see how we did on the supplements. Chris, supplement of 80 degrees.
Is that 100 degrees?
It is 100 degrees for 120 degrees.
60 degrees.
Good. 76 degrees, 37 minutes.
103 degrees, 23 minutes.
Good. 98 degrees, 57 minutes.
81 degrees, 3 minutes.
146 degrees, 6 minutes.
33 degrees, 54 minutes.
And for perfection, 121 degrees, 45 minutes.
58 degrees, 50 minutes.
There we go. Got them all. Excellent job, sir. Any questions? Any questions? How many perfect on all the ones you did? Even if you didn't finish them all, of the ones you did, you got them all right.
All right.
All right. Any questions at all on those? And notice they were pathetic and they didn't give you any of the seconds ones, even though you're definitely smart enough to do with seconds. They just stayed with minutes. But I'm the one who writes your tests. I'll probably have seconds, bless you, on quizzes and tests because I don't want to insult your intelligence like that.
Sure, yeah.
But anyway, questions on that? Yes, ma'am.
For number 5, what was the third one?
For 76 degrees, 37 minutes was 103 degrees, 23 minutes. What did you have?
I had 94, but I mistook my 179 for 170.
Ah, I gotcha. Okay. All right. Any other questions on those? All right. Next thing in your notes there in the class notes section is converting degrees, minutes, seconds into decimal degrees. Converting degrees, minutes, seconds into decimal degrees. You realize a minute is a part or a fraction of a degree. A second is a part or a fraction of a minute. And normally, instead of using fractions in our degrees, we would use decimals. For instance, we might say that something is 38.2 degrees, right? That would be not entirely unnatural. But what if we were given degrees, minutes, seconds, and we wanted to convert it over? For instance, write this in your notes, if we had 35 degrees, 15 minutes. What we would want to do first is to take the minutes that were given and make them a fractional part of a degree. So let's convert this, writing this down in your notebook with me, as 35 and 15/60ths degrees. Do we understand what we did here? 15 minutes is 15/60ths of a degree, because what is a minute? It is 1/60th. Well, we have 15 of them. That means we have 15/60ths. Make sense? And then in your calculator or in your head, what is 15 divided by 60? 0.25. So then this equals 35.25 degrees. So instead of 15 minutes, 0.25 degrees gets tacked on. Does that make sense? So 15.25 degrees. Let's do another one. Write this one down. This one's a little bit more challenging. 27 degrees, 32 minutes, 45 seconds. We're not going to be able to go straight to degrees this time, but we do know every second class is what fraction of a minute? A 60th, but I've got 45 of them, which means I have 45 60ths. Do we see that? So write this down with me. 27 degrees, 32 and 45 60ths minutes. We're taking the 45 seconds and making it 45 60ths of a minute. Now, let's make the 45 60ths a decimal. 0.75. So now we've got 27 degrees, 32.75 minutes. We've taken the 45 60ths minutes and made it 0.75 minutes. But realize every minute is what fraction of a degree? A 60th. But we've got 32.75 of them. So now we can make this 27 and 32.75 60ths degrees. So we just keep taking the part and making it 60ths of the next thing. So since we have 32.75 minutes, that's 32.75 60ths of a degree. Go and divide the 32.75 by 60. And what do we get? 0.556. It keeps on going for a while, doesn't it? Okay, but we could say we've got 27.556 degrees. Someone else verify?
Yeah.
We got the 0.556, blah, 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 and keeps on going?
Just threes after that.
Threes after that, okay?
Just threes.
Oh, just three. So we could say 27.5563 repeating degrees. And that way we don't even have to use the little dot, dot, dot. It actually shows which digit is the repetent. All right? Do we see how to do this? Try this one at your seats. 72 degrees, 10 minutes. 72 degrees, 10 minutes. Again, if a decimal repeats, I would prefer the repeating part of the decimal as opposed to just kind of blah, 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 if possible. We take the smallest unit, going over 60. What we got.
I got 72.167, I just rounded up.
Okay, well we want the repeating digit if we've got one. Okay, so if you see 6, okay, go ahead and just put the 6 with a little line over it for the repeating.
It isn't repeating, it's 7, I think.
Oh, because you've got a fixed set on your calculator? No. Okay, sorry. It's not 0.167, it's 0.1666666, and then the calculator rounds that last digit. But because you see that many 6s in a row, it's really a 6 with a 6 hiding after that bumped it up. But we would just put the 6 with the line over it. Good question. All right. Do we think we get the idea of putting it over 60? All right, now for the tough one. 98 degrees, 13 minutes, 30 seconds. 98 degrees, 13 minutes, 30 seconds. Remember, don't try to do the degrees at first. Just convert the seconds to minutes first. decimal.
No,
You're good.
but I, rounded 98.23.
Well, no, don't round it, just go till it stops or go till it repeats if possible. So you had it, right? Yeah, just so go ahead and write the whole thing out, it's only one extra digit. Good, you got it as well? You also got it? Audrey did not.
Coming out in fractions.
Oh, yours is in fraction form, that's annoying, okay. Let me fix that for you. Let's see if I got it fixed now. Well, for now, put fractions, and I will, I'll take a look at your calculator and see if I can figure out how to fix it, because I've seen calcios and they look similar, but it's not giving me the options I'm used to on there, so we'll deal with it later. For now, at your sheets, sorry, do number 6. Now at your sheets, do number 6 there on page 15.
Number 6.
Number 6. Okay. What you can do, Audrey, when it gives you something like that, let's say it gives you like 9 divided by, or let's actually plug something in. Let's say it's like 14 divided by 60. It's gonna give you the fraction right here. If you hit it, it'll give you the decimal instead. Yeah, so just that button there. There should be a way to turn it off so you don't have to do that every time, but it's an easy fix there.
Okay.
That's it, FX 300, yes please. See if I can figure out a way to turn the automatic fractions off. Usually something called math print, I'm not seeing that option on your calculator. Let's see what we got for our answers. Number 6, what'd you get for 50 degrees, 30 minutes? That was pretty straightforward. Kendall?
50.516.
Oh, for 30 degrees? Should just put 30 over 60, which should come out to 0.5 evenly. So it should have just been 50.5 degrees. Wonder if you made that one harder than you should have. What about the next one, Kendall? 85 degrees, 45 minutes?
85.75.
Okay, that one you got the correct answer, 85.75 degrees. And what about the last one, the 125 degrees, 20 minutes, 30 seconds, Chris?
125.3416 repeating degrees.
Good, 125.3416, and that 6 repeats degrees. How do we do on number 6? We get all the ones we did correct. Any questions at all? All right. Take a look at number 7, and go ahead and read that first question for us, if you would, Genesis.
How many degrees are 1/2 of a right angle?
All right, how many would that be, Genesis? Half of a right angle. 45 degrees. What about the next part there, Audrey? What about the next question?
Oh, 1/3 of a straight angle.
And how many degrees would be in 1/3 of a straight angle? 60, because 1/3 of 180. What about the last one there, 1/5 of a paragon? Chris? 72 degrees, good. Number 8, if two complementary angles are equal, what is the size of each? At your seats, figured out. Two complementary angles are equal. What is the size of each? I think I actually referenced this on Friday. Chris has it. Two complementary angles are equal. What is the size of each? Ethan's got it also. Audrey's got it. Ethan, what you got?
So 180?
Well, that would be the sum of two right angles, but we're saying there's two angles that add up to
360.
90. Two angles that add up to 90, so they both have to be small enough that they're equal to each other. Audrey? 45, right? If you had a 45 and another 45, those are equal, but they add up to 90, so they're complementary angles. Does that make sense? You're trying to add two 90s as opposed to adding two things that gave you 90. Make sense? Let's jump down to number 10. We'll come back and do number 9 in a moment. They've given us a couple of, actually a few straight lines that all intersected at the same point. They told us that we've got these different angles, A, B, C, D, E, and F. And they told us that angle A is 70 degrees, and that angle C is 60 degrees. They want us to find the other angles. Now, we looked at this picture once before, and we actually drew a conclusion about something going on in this picture. Chris, do you remember what conclusion we drew on Friday as we looked at this picture, just we didn't have the degree measurements?
That the opposite side is the same angle.
The opposite side, what do you mean by that? There's a term from your terms and definitions I'm looking for here.
The, not parallel, it's a type of angle too.
It is a type of angle. It's a something angle. For instance, what you're thinking of is angle A and angle D, right? These two angles. What do we call those angles?
Not perpendicular.
They go right across the vertex from each other. Help in class. Vertical angles. Class, say that with me? Vertical angles. There we go. But Chris is right. We drew the conclusion. We actually proved, in fact, based on principles and facts that we learned, that vertical angles have to be equal. So how big is angle D then, Chris? 70 degrees. What's another angle I know just like that? Kendall?
F.
Angle F has to be
60.
60 degrees. So the question is, how do I figure out the remaining angles? What do you think, Genesis? If I know A, I know D. If I know C, I know F. So if I knew B, for instance, I would know E, but how do I get B?
Would it be 70?
Ethan, what do you think?
You add 60, 70, 70, and 60, and then you minus that from 360.
Okay, so Ethan has an idea. He said, well, if we know all of these together add up to 360, then we know so far I've got 60, 70, 70, and 60 spoken for. Anyone, how many degrees is that total?
Just 100.
That's 260 degrees so far, right? So we've got 260 degrees spoken for out of 360. So that leaves us with how many degrees, Ethan? 100. 100 degrees, yeah, I thought you said that. I'm like, all right, so does that mean that angle B is 100 degrees?
50 degrees.
50 degrees, because if these are going to be equal, they've got to share the 100 degrees evenly between them. That's one way to do it. There's actually a slightly easier way. Anyone think of another way? Without adding them all together to get 360? If this is a straight line, then these three add up to a straight angle, which is 180. So I've got 130 subtracted from 180 gives me 50, and therefore this is also 50. That's another way we could have gotten
Yes,
that
it is.
as well. All right. Only homework tonight. Study. Memorize everything in your notebooks. Okay? Study, study, study tonight, but no written homework. Have a wonderful rest of your day. You are dismissed.
Ethan.